Welcome to Mr. V Teaching Math. In this session, we're going to look at multiplying numbers by tens, hundreds, thousands, and so on. I'm going to do it the long way first. Okay, there's nothing I can write, so I could put all zeros, going 0 times 8 and 0 times 5 if I really wanted to. I do 1 times 8 is 8, 1 times 5 is 5, and I can do all of this the long way. I have one number behind the decimal. 5.8 becomes 58. Again, I could do all of this the long way, although I'm taking a little bit of a shortcut this time. One number behind the decimal. The key thing to notice, though, is I'm timesing by 10. I'm increasing the place value by 1. I'm moving the decimal one space. Timesing by 100, I'm increasing the decimal, increasing the value by 2 place values, moving the decimal 2 spaces. This pattern continues if I go into the thousands. So I can know that if I do 5.8 times 1,000, I'm going to increase the place value by 3 spaces. So rather than sitting there and doing all of this calculation, I can simply go 5.8 and it's going to go 1, 2, 3 spaces over, which would, and I'm going to have to fill those spaces in with place value holders. And I can continue the pattern. So rather than actually sitting there and doing all of this kind of work, I can simply look at how many place values this is going to increase. And how do I know how many place values it is? Always remember that there is one ones. There's 1, 1. So that place value really doesn't count, because when you're multiplying by 1, nothing changes. But you have 3 more place values to work with. Now that's easy enough to do, multiplying by tens, hundreds, thousands, 10,000s, 100,000s, and so on. What many students struggle with is when we start to multiply by a decimal. So let's do a similar example, but now I'm going to multiply by a decimal. Doing my long form of multiplication, 1 times 8 is 8, 1 times 5 is 5. How many numbers are there behind the decimal? I have 2 numbers behind the decimal. Again, 1, 2, 3 numbers behind the decimal. 1, 2, I need a placeholder. Notice the same pattern. I could, again, use the same technique. I'm going to have to move it 1, 2, 3 spaces. This is going to move over 3 spaces. 0, 0, 5, 8. That was 1, 2, 3 spaces. Sorry, I ran out of room on my paper. Notice the difference from this to dealing with this. How many spaces do I know to move it? Well, there's only 1 ones, and you never count the ones place value, but I have to count the other place values. That's how many spaces you move the decimal. The same trick can also be used if you are going to be doing division. If I take a number like this and divide it by 10, now I could do this the long way, and I could take my number and set it up like this. 10 into 6, it doesn't work. 10 into 67 goes 6 times. I'll need another 0, bring the 0 down, goes in 7 times. And I could do all this work, but notice, between here and here, all that happened is the decimal moved 1 space. I can again apply the same process. 6.7 divided by 100. I'm going to move it a bunch of place values. Now how many? This one doesn't count because it's the ones, so I never count this one. I'm counting 1, 2 place values. This decimal is going to go 1, 2 spaces over, and it would look like this. The original decimal was here, and it went 1, 2. Again, I can use the same technique when I'm dividing by a decimal. If I do this the long way, don't want to do this with this decimal here. I'm going to move that decimal over, which means that decimal has to move, which puts it here. 1 into 6 goes 6 times. 1 into 7 goes 7 times. Again, notice the difference. This is 67, that was 6.7. It caused me to move it 1 place value. So I can extend that technique, divide by 0.01. How many place values am I going to move it? This one doesn't count because this is the ones. And I've got 1, 2 place values to move it, and it's going to go 1, 2 place values. Original decimal was here, and it went 1, 2. The greatest difficulty is remembering when you're timesing by 10, dividing by 10, timesing by a decimal, dividing by a decimal. Which way do I move the decimal? That is the hardest thing to remember. Most of us can remember that when timesing by 10, it makes the number bigger. That's a good place to start. Division is the opposite. The minute you get into decimals, reverse it again. This is the opposite of that. These two actually do exactly the same thing, and these two do the same thing. Hopefully that'll help you when you're multiplying and dividing by tens or decimals that are just a 1.